So this topic wants us to set up a reaction table to calculate the pH for a system where we have a common ion. So the common ion is the new part of this. And a common ion is a way to summarize when we have an ion that has two different sources. Okay, so two or more sources for the same ion. Now, in our context, we're going to be often given an acid or a base. And then we'll have, in a separate source, we'll have the conjugate as well. Okay, so what do we have in this problem? Well, in this problem, we've got the weak base, methylamine. So methylamine, since it's a weak base, it's going to hydrolyze when it gets into water. So we'll have CH3 NH2 reacting with water, giving us the conjugate acid, CH3NH3 plus OH minus. Okay. The common ion in this problem comes from the fact that we also have the conjugate base, the methylammonium, in the form of methylammonium chloride. Okay, so we've got one source of methylammonium, which is as the conjugate acid of the weak base. And then we've got an additional source, which is the salt from the methylammonium chloride salt. Okay, now how we're going to handle all of this is by including both of these things, both the weak base methylamine and the conjugate acid methylammonium. We're going to include those in our reaction table as initial concentrations. Okay, so Alex has given us the start to an ice chart, except they have an ICF chart. ICF doesn't make a nice word, ICF or something like that. So I always kind of think of this as still being in equilibrium. And that way I just think of it as a nice chart. Okay, so let's put in our initial concentrations. So we're given 0.49 molar of methylamine, and we're given 0.25 molar of the conjugate acid. So let's go ahead and put those in for the initials. So we're going to have 0.49 for the methylamine, and we're going to have 0.25 for the methylammonium. That 2 was really lame. I'm going to take another shot. There we go. That's better. That's a sexier 2. Okay. And let's assume that we don't have any OH, although we're going to calculate that in a little bit. Let's also clean up some of the stuff here. We need to have a double arrow in there, and we need a plus sign in there. Okay, so this reaction, as it proceeds towards equilibrium or toward the final condition, is going to move to the right. Because there's a 0 here, and it's going to try to fill in the 0 in the products. So we're going to have a minus x, and this methylammonium is in the product side. So we're going to have a plus x, and we're going to have a plus x. Then the final situation, or the equilibrium position, is going to then be 0.49 minus x, 0.25 plus x, and x. And then if we wanted to solve this thing, to take this to the next step, then we'd have our KB is then equal to X times 0.25 plus X all divided by 0.49 minus X. And we would solve for X. In that case, and that would give us OH minus, and we'd be off and running to calculate the pH. And that is it.